Hi, welcome to my channel. This is A. Nageshwar Rao, Associate Professor, Department of CSC, CMR Institute of Technology, Hyderabad. In previous video, I discussed about introduction of an algorithm. Today, I'm going to explain. In this video, I'm going to explain what are the properties of an algorithm. Properties of an algorithm, or we can also call it as criteria of an algorithm. Either properties or criteria. Properties or criteria of an algorithm. For any product or any item has some properties. Here also, according to software, so whatever the product or whatever the end result we get or we design, that end result is called product. Okay, na? So here also that particular product has some properties. Here there are five important properties, five main properties here. I'm going to discuss those five properties now. So first one is input. Very, very important. The first one is input property. First one is input property. And I'll write and I will explain. Input. First property is input. So what do you mean by input? Relate this input to our designed algorithm or program. Okay, na? So generally, algorithm may take either zero input, one input, or more number of inputs. I will give one example, more number of inputs. This is first property. Okay, na? For any designed problem or any designed program, it must take some inputs and produce the required output or useful output. Is it clear? Okay, na? So what do you mean by zero input? What do you mean by zero input? So every algorithm or every designed program or every designed algorithm, any product, it must take inputs. Is it clear now? It must take inputs and produce at least one useful output. But with respect to input, the algorithm or program may take either 0, 1 or more number of inputs. 0, 1 or more number of inputs. I will give example for 0. Okay, now suppose I'm not going to write the complete program here. Just I am introducing a statement. Suppose if you want to add two numbers, I want to store a result in another variable. Suppose the variables are like this: a comma, b comma, c. These three are three different variables or of type integer, whatever it may be the data type. You can also declare these items in floating point. But if you at the declaration part itself, if you write the declaration part like this: suppose a equal to 2, b equal to 3, and c. Okay. Suppose if you involve the statement like c equal to a plus b, c equal to a plus b. In this case, the duty of compiler is generally whenever any operation is identified by the compiler during running time, it must perform that operation between the specified operands. Okay, na? So here at the time of writing program or writing algorithm, if user supplies a value and b value, so during execution, during compilation process, compiler allocates space for A and space for B, and also stores 2 against A and 3 against B. Means these two values are available in the memory in advance. So during running time, processor can easily extract A and B values from its located memory, and which performs operation between A and B. Addition operation between A and B produces C. It stores the result in C. Is it clear now? Is there any input externally required supply? Is there any input supply externally? No, because we made inputs available to the machine in advance. At the time of writing itself, we are supplying A value, B value to algorithm, and the compiler stores A value, B value in computer memory. Whenever you are running algorithm or program, processor automatically gets those two values from the computer memory because those two are already available. So he in this case need not to supply any input externally or through keyboard. A user need not supply any input through keyboard. Is it clear now? And this is for zero input. Suppose the same example if we take, and instead of supplying elements, if you simply declare the values, I'm not writing programming statements here, but in between C equal to A plus B and the declaration part, some more statements are required. Those statements are used for reading A and B value here. Is it clear now? So how many elements required here? 2 elements. Here A value is required, B value is required. But during compilation time, compiler cannot know ABC values. Is it AB values? Is it clear? So the compiler job at the time of compilation is simply allocating memory to A, B and C. During running time, the user can make A and B values available. Is it clear now? So here user is supposed to enter 2 elements. So this is regarding input. So algorithm or program which may or may not take input externally through keyboard by the user, which second property, I will explain second. This is about first property. Second property is output. Second property is output. So once input is over, either you supply input externally, or if you make that particular input available in advance in the computer memory, but whatever the algorithm you design, whatever this program you write, that must produce at least one useful output. Otherwise writing algorithm is wasteful. Is it clear now regarding output? Second property or criteria is output. So whatever the algorithm, even you write 2000 lines code or 2000 lines algorithm, if you don't get the required output or useful output, what is the use of writing that much code? Is it clear now? So whatever the algorithm you write, the first property is algorithm must take either 0, 1 or more number of inputs externally through keyboard or via any other media by the users, but it must produce at least one useful output. This is the second property. And third property is definiteness. This is the third property here. Third criteria, definiteness. So what do you mean by definiteness? What do you mean by definiteness? What is definiteness? What do you mean by definite? Definite means generally we are including statements into algorithm or program. Those statements must be clear and unambiguous. Please remember this, unambiguous. What do you mean by ambiguity? What do you mean by ambiguity? What do you mean by ambiguity? Confusion. Suppose your statement is containing more than one meaning. Then compiler confuses which meaning is suitable for your respective problem or your problem for getting the solution. So sometimes the system is stuck. Suppose if more than one meaning is there for the system falls into unambiguous state. Ambiguous state, it gets ambiguity, and which cannot relate the appropriate meaning to your problem. So whatever the algorithmic statement you write, that particular statement must be very, very clear, and it should contain only one meaning. I will take the example here. Suppose if we take the above statement, C equal to A plus B. Suppose A and B are of type integers. Then if we write the statement like C equal to A plus B, then through this particular instruction, we are informing the compiler that add two numbers A and B and store the result in C. Only one meaning is there. That meaning is adding two numbers and storing the result in C. So such type of statements you are supposed to include in your algorithm. Okay, na? The statement must be clear, understandable, and every statement should be unambiguous. There should be no more than one meaning for each statement. Is it clear? Okay, na? So this is about third property. And fourth property is finiteness. Very, very important. Finiteness. Fourth property is finiteness. Okay, na? So what do you mean by finiteness? What do you mean by finite? Countable. Finite means terminated. Okay, na? So whatever the algorithm you write, that algorithm must be terminated after some instructions. Every algorithm should be terminated after some instructions. Means the countable number of instructions we need to write. Countable number of instructions we can write. Suppose when can it be possible? When this particular finiteness is possible. Suppose if you take problem P. If problem P can be solvable. If problem P can be solvable, always the solvable problems are requiring finite number of steps. Solvable means we can get the result from that. Solvable means we can get the result from that. So all the solvable problems are requiring finite number of instructions. So we can say like suppose finiteness of algorithm means algorithm must be terminated after some instructions. After writing some instructions, the algorithm must be terminated. There is an end for algorithm, because we cannot write infinite number of instructions. We cannot write, because infinite means cannot be defined. We cannot define infinite number of steps. Okay, if any problem can be solvable, then that particular problem is always requiring finite number of steps. Then as a programmer or a developer, we can write the required number of statements, and finally we can end the procedure. Is it clear now? So this is the fourth property. And fifth property or fifth criteria is effectiveness. Effectiveness. Then what do you mean by effectiveness? This is also very, very, very important. Effectiveness means whatever the instructions you are including, those instructions must be basic instructions. Basic instructions, and those must be carried out. Those must be carried out whenever you want to analyze, or whenever you want to trace out. Whenever you want to trace out all the instructions, those instructions can be carried out by human or developer. Okay na? By taking pen and paper, we can analyze all the instructions, either for calculating time complexity or either for calculating space complexity. The instructions must allow the user or developer to carry out completely. So whatever the instructions you are writing, those instructions must be basic, and also you need to remember, must be related to your algorithm, related to your algorithm or problem, related to your algorithm or problem. Otherwise those statements goes wasteful. Okay na? Suppose if you want to add two numbers, the instead of declaring two numbers, suppose if you declare it like this, a b c d, but actually we are involving c equal to a plus b in our procedure, but unnecessarily we declared c. Not only this, some statements may be unnecessarily included. Suppose it's not two problems program is the aim, but you also included d equal to a minus b. What is the use of this? What is the use of this statement? Because our target is adding two numbers, but unnecessarily we are including subtraction of two numbers also. This is not required here. This is not required, but not actually. But my intention for saying regarding this particular one is, whatever the problem that is given to you, you have to include only the related instructions to your problem, program or algorithm. Okay na? So then only we say that all the instructions are effective and related to your problem. So whatever the instructions you are writing, those instructions must be basic instructions, and those must be carried out by human. By taking pen and paper, you must be in a position to trace out all the instructions. Okay na? So, and all the whatever the instructions you include in your algorithm, those must be related to your algorithm or problem or program. Okay na? Unnecessarily don't include non-required instructions in your problem. Of course, that is nothing wrong including those instructions, but those are wasteful, because our intention is adding two numbers. In addition to two numbers addition statement, if you include a subtraction also, actually subtraction is not required here. So you have to take care while including instructions. Identify which instructions are suitable for your problem. Such type of instructions only include into algorithm or program. So we treat these five properties as properties of an algorithm, or criteria. Sometimes we treat it as criteria or properties, anything, either criteria of an algorithm or properties of an algorithm. If this particular question is asked in exam, explain about criteria of an algorithm or properties of an algorithm, you start with the input and end with the effectiveness. Okay na? Input is one property. So once again I will explain. Algorithm may take 0, 1 or more number of inputs externally, but it must produce at least one output, otherwise writing algorithm is wasteful. Okay, so what is definiteness? I have already told. Every instruction, whatever the instruction you include, that instruction must be clear and unambiguous. Unambiguous means confusion. Through statement, if you confuse the compiler, sometimes the compiler will get stuck. Okay, it won't go further. or it produces wrong result by relating this particular one to another meaning. Okay na? So you have to write the instructions like very clear instructions, and that must contain only one meaning. And next property is finiteness. All the instructions or all the algorithm must be terminated after some steps or instructions. So it is possible when and only when if the problem can be solvable. If problem can be solvable, always solvable problems are requiring only finite number of instructions. That is finiteness. And the last property is effectiveness. Your instructions should be basic instructions, and that those must be carried out. Okay na? And whatever the instructions you include, those must be related to your problem or algorithm. Is it clear now? So you are not supposed to include this statement for adding two numbers. Okay na? Of course you get result here if you include the D, A, B properly in your program. Of course that statement may be treated as a correct statement by the compiler, but that is unnecessary statement in our problem. So these are the properties of an algorithm. And in a previous video I explained introduction to algorithms, but I forgot telling the definition of an algorithm in a very easier manner. So I have already given some definitions, step-by-step procedure for solving the problem, or sequence of statements that are required to solve the problem, or group of instructions which are required to solve the problem. Like that, some definitions I have written in previous video. But it is very easy remembering definition of an algorithm by splitting, because if you generally Britishers followed divide and rule for ruling the country very easily. So like that, some English words and Telugu words or any other language words, we can get the meaning very easily by splitting that particular word. Here also I am going to show very easy way of remembering algorithm definition. This my intention is just dividing that particular algorithm word into three different subwords: algo plus rhythm. Okay na? Like that I divided the algorithm word into three parts or three subwords. So need not by heart algorithm definition here. Just I'll write here what is all, what is go, what is rhythm. Just if you remember this, so need not worry about the definition of an algorithm. Lifelong we can remember this. What is all? Just to relate these three words to the computer. What is all? All means all the instructions. What is all? All means all the instructions. All the instructions. What do you mean by go? What is go? What is go with respect to computer? Go means generally running or execution. Execution or run. Go means either running or executing. What do you mean by rhythm? Rhythm, well-known word. Rhythm. Rhythm means sequence. Rhythm means sequence. Is it clear? Now combine these three words related meanings. What is all? All the instructions. Go means executing or running. Rhythm means sequence. Now we got the meaning now. We got the definition of an algorithm. All the instructions are executed in sequential manner. This is the definition of an algorithm. Most of the words in all the languages, generally we remember the words related meaning by splitting that word into three meaningful subwords. Then only we can remember easily. I shown how we can remember algorithm definition. Okay na? Just by splitting algorithm into three different subwords. Is it clear? Is it clear? Now in this video I want to explain about the properties of an algorithm and the definition, the definition how we can easily remember algorithm definition, how we can easily remember just by splitting algorithm into three subwords. Okay. Thank you so much. Thank you so much.